Well, howdy everybody. Hopefully you're doing good. It's me. How's it going? That's probably a little much, but you know what? We're here to solve these problems out. We're looking at the forces review. This is the 2021 version. Probably hasn't changed much over the years. So, number one, we got someone jumps from a plane and reaches their max speed. Then they open the parachutes. Let's look at what's going on at their max speed when they're at that terminal velocity. When they're at the terminal velocity, the person's feeling a weight force and a friction force at that moment, and they're equal because they're going constant speed. When they initially jumped out of the plane, they just had a weight force, right? No friction yet, because the air wasn't doing much, and then the friction got bigger and bigger and bigger and bigger and bigger until this point here. And then they open a parachute. Well, they're going this way, but they're going to slow down, so their acceleration is in the other way. Well, what does that mean? That means that there is more force upwards at that moment. And so you have a larger upwards force. Some people will refer to it as normal force because it like shoves in their armpits. That's cool. We'll take that too. You get the parachute. Okay, never mind. All right. Box is sliding on the ground, moving to the right. Well, if a box is sliding on the ground, moving to the right, it's going to the right. It has a normal force, and it has a weight force, and it has a friction force. It does not have a forwards force because nothing is pushing it. 3, inertia. Inertia is mass. That is the big idea. So which is the most massful? B. Has 12 kilograms. What's the next most massful? Is A. And then who's the loser? C. Because C is only 6 grams. Even though it's moving fast. Inertia is the idea of mass. It's a property. All right, number 4. Number 4, make sure you guys can see this. Yep, just checking it out real quick. And so number 4 here, just because we're doing math, we can get that zoomed in. 4, you push a hockey puck with 32 newtons of force, and there's no friction. Okay, so you're going to hit the thing with 32 newtons of force. There's no friction, so you have a normal force and a weight force. Well, if there's no friction, F net equals MA. So 32, what's the mass in this one? 0.22, solve for acceleration. I might as well do this, double check all these answers. 145. Wow. Well, you are hitting a slap shot in hockey. I guess we'll call it good. 5. This is where it's to get to the bread and butter. You got a 4 kilogram mass. You push it with 10 newtons. So you push it with 10 newtons, and there's 7 newtons of friction. What is the acceleration? Well, here's a normal force, here's a weight force. So if I do F net equals MA, my net force is 3. My mass in this problem is 4, so solve for acceleration. I get 0.75 meters per second squared. Number 6. 3 kilogram bird flaps its wings at 35 newtons. Draw a picture. 3 kilogram bird has a weight force of 30. And it has an upwards force of 35. So if I do F net equals MA, got to use that picture. So my F net's only 5. And so your acceleration is 5/3, which is 1.67 meters per second squared. But to be thorough, I should say 1.7 meters per second squared for number 6. Yep. Sorry for rounding incorrectly the first time. All right, number 7. Number 7, now we're getting to coefficient of frictions. So number 7 here, a 12 kilogram block of wood is moving across the floor. You push it with 30. All right, here we go. So you push it with 30, and it accelerates. So they give you an acceleration. So we're going to do F net equals MA, and they give you an acceleration of 0.2. I'm just going to write that down, 0.2. And what's my mass in this problem? 12. Okay, I got some info. So I know my F net is 12 times 0.2 is 2.4. Okay, well, hold on. Whoa. You pushed with 30 newtons, but you only got 2.4 newtons of F net. Well, that means you got friction of all people. How much friction? 30 minus that answer, 27.6. So your friction force is 27.6. Okay? If that's all you do, it's a great start. The next question is, what's your coefficients? So F equals mu n. So the friction is 27.6. And your normal force is the in this case, the weight force is 120, and the normal force will also be 120. So 120. So 27.6 over 120.23. That's number 7. Number 8. Let's see if we get this on here. Push a total carry-on box with 12 newtons of force and moves at constant speed. Ooh, sweet glory. So you've got yourself, you push it with 12, and it goes constant. That means your friction is also 12. Okay? Now you push on the same surface with 15. What? Well, what's it going to do? It's going to accelerate, right? The question is, what's the friction? The friction is still 12. Because friction force does not depend on speed. So as you speed up, the friction force will be identical. Now it says, what's the acceleration? F net equals ma. 3 equals, what's the mass in this one? 10 kilograms. Okay, there we go. There's number 8. Let's see, now we're on 9. Elevator. We got ourselves an elevator. Elevator gets weird. It says it weighs 1, 2, 3, 4 newtons. That means its mass is 123.4 kilograms. So we got to start there. Okay, so whenever I see problems like that, I don't even read the problem. I just fix that first. Okay, so the elevator weighs, so I'm going to draw that on there. It weighs 1, 2, 3, 4. And then it says it accelerates upwards. Ooh, so F net equals ma. I've got an acceleration. What is it? Upwards at 0.5. Okay, and the mass is 123.4. So I got my F net. I just got a number. Okay, remember, this is a habit. Whenever you see acceleration, just get it. 123.4 times 0.5 is 61.7. All right, so let's just stop here. So let's not do any math, right? Let's say we didn't do that, right? It says it accelerates upwards. Well, which force has to be bigger? The upwards force. So the tension will have to be bigger on the elevator. It's a cable pulling on it. So that's yep. So it's going to be bigger. How much bigger is my net force? So this is 1, 2, 3, 4 plus 61.7. I get 1295.7, which rounds to 1296 newtons. Number 9. All right, I'll fix that on the key. All right, number 10. Bucket's been pulled upwards at constant speed, and the key to this one is that the tension and the weight will be identical if it's going at constant velocity. That is key. So to get something to a constant velocity, you have to support it to weight. You have to have those balanced out. If not, right, you're going to have more force down or more force up. You're not going to be on constant. 11. Box is straight chilling. There we go. We got a box. Got a box number 11. 3 kilogram box is just chilling on a rough surface. The coefficient of static friction. So whenever you do these, they give you two things. They give you static and kinetic. So I'm going to start with just finding out what these quantities are. 3 kilogram box is 30 newtons of normal force. So that's 24 newtons of friction. And then kinetic, I'm going to get a friction force of 9 newtons. Okay? So this is static. This is the number that has to be overcome. This is kinetic. This is when I'm sliding. Okay? So let's start here. So part A, situation number 1. I've got you pull it with 5 newtons. If you pull it with 5 newtons, is there enough force to get it going? You have to pull with 24 newtons to get this thing going. Did you pull with enough? No. So this has a velocity of 0, an acceleration of 0. It is not moving. Okay? Well, here's normal, here's weight. If you pull with 5, that means the friction has to be identical. Okay? And that means your acceleration is 0. Okay? Part B. On the same problem, we are going to pull it with 15. Well, did you pull enough to get it going? No. So how big is the friction? 15. What's your acceleration? 0, because it ain't moving. Okay, part C. Now you pull at 25 newtons. Let's take a quick peek. You pull at 25 newtons. Well, did you pull enough to get it moving? Yes. It is now moving. Well, if it's moving now it has sliding friction. Because it's moving. You were able to overcome that. So now you're moving. So now you've got 9. So here I can do F net equals ma. So my F net from this picture is 16. My mass in this problem is 3. So I get an acceleration of 5.3. Okay. Part D. Part D. Once you get it moving, now you pull it with 9. So it's already moving, and you pull with 9. It's moving. It's moving. If it's moving. If it's moving, you're sliding friction. If you pull with 9, sliding friction is 9. What is it going to do? It is going to go at constant speed. And if it goes at constant speed, it means your acceleration is 0, because acceleration is changing velocity over changing time. But if you're going constant speed, you are not changing. No change for you. There we go. All right. That was 11. 12. I'm going to put some stars on the ones that are a little bit tougher. So I'll make sure that's really clear. So those are kind of the ones where it's like, all right. I see where you're going. So 12. You got a 400 kilogram train is moving to the right. See, I wrote this. Remember that movie, The Train That Never Stops? This is a great movie. So we got 400 kilogram trains moving to the right at 40. Whoa. What are they doing here, people? That's right, people. You can get this at the student store. So we've got ourselves an initial velocity of 40 meters per second. It goes how far? Does it say? Stops in 500 meters. And the final velocity, since it stopped, is 0. Well, forces are not going to get me time. Forces are going to get me acceleration. Okay. So I'm going to play with the acceleration here. What's the question? It's saying, how large is the friction force? So I've got this. Over here, I've got a weight force. I have a normal force. What else is stopping this? What is actually causing this thing to stop? Well, it's friction. That, if I knew what that number was, I would know the net force. I could talk acceleration. So watch, if that friction was like 1,000, well, that means my net force is 1,000, right? And that's able to talk with acceleration. So we're going to do this. F net equals ma. If I know the acceleration from over here, I can plug it in and get a value. Could I then use that F net to get my friction? All right, so we're going to do that. We're going to play over here. Take a second, pause this, make sure you guys choose the equation, try to set it up. So we got VF squared equals V initial squared. This is the third equation, equals A delta X. So final is 0, initial is 40. Don't forget to square it, 2A delta X. So I'm just going to simplify things. I'm not going to skip any steps. So I solve that, you get an acceleration of negative 1.6 meters per second squared. 1.6. So I'm going to plug that in up here. Mass train's 400. It's a little train. Times 1.6. So you get 400. So I get 640 newtons. That's my net force. Well, if that's my net force, let's go up to my picture here. If my F net's 640, this has to be 640 newtons. If there was a force here, I'd have to do some subtracting business, but since that is the only force that is stopping me, that's the only force happening horizontally, that's it for number 12. Big 1-3. All right, 13. This is based off of some of the most recent stuff we've done. And so we've got ourselves, you got a sled, and you pull it with 30 newtons at an angle of 40 degrees. Okay. The question is, what's the acceleration? All right. Well, we're gonna do everything on this one, though. But we've got ourselves a weight force of 50 newtons. Okay. So now, remember what we said. So whenever you have a force at an angle, break it up into its two parts. Okay. So the horizontal will be 30 cosine of 40. The vertical will be 30 sine of 40. Okay. We're just going to plug those into calculators and just see what we get. All right, so they just have some numbers. So a way to think about this is this 30 newtons that you pulled with, when you do that, come on, I'm going for the super cool visual right now. So when you do that and you have that value of 23 sideways and 19.3 going up, what you've done is you've replaced this force with these two red forces. That's what you've done. When you break something into components, you've literally said, instead of having that overall thing, I have these two things. That's what the components do. So now, if I got 19.3 going up for this guy, right? I got 50 going down for this guy. Well, that means the rest is my normal force. My normal force is 30.7. Okay? Now, they're asking me for acceleration. So I didn't actually have to do net force. So if I do F net equals ma, well, the mass in the situation is 5. But what's my F net? My F net is how much I'm pulling in the direction of motion, which is 23. If there's friction, right, I'd subtract it. This problem doesn't have that. So I get 23 over 5, 4.6. So there's number 13 for you. 13, acceleration is 4.6. Good morning. And so, all right, 14. Recorded, it's all good. 14. Doing a great job.
Hi, video.
Rank the tension in the diagram. So this one is a steep angle, and this one is a shallow angle. And the idea with this is the steep angle has two components, has horizontal and vertical. And the key is these two horizontals have to be equal to each other because they're pulling each other sideways. But these two verticals are what cancel out the weight. But look at this. If you are at a steeper angle, a bigger angle than this guy, you will always be supporting more of the weight. And so A will always be more. Okay, 15. If you're new to trig, 15 is the most difficult one on here. So we've got a weight force of 20 newtons. Okay, pull at an angle, and you pull sideways. This is 30 degrees, they said. Okay, so what we do is we break this guy up into components. So this is 20 going down, that means this is 20 going up. There you go, that's it. Because these guys have to cancel each other out. Well, the question's asking you what is this tension and what is this tension. And so what you got to do is you got to somehow use this triangle to find these other guys. One of the ways to do it is we know that this vertical guy, the vertical guy, equals the overall tension times sine of the angle. That's one way you could do this. Okay. You could also, right, do your SOHCAHTOA if you're comfortable with that. That's another way to do it. But doing this, you could solve for t equals 20 over sine of 30. And so you get the tension is 20 over sine of 30. You get 40. So that means this tension is 40. Well, this guy over here, how am I going to do that? I'm going to change color. Well, this guy cancels out this guy. So what I got to do here is I go, okay, well, if I know that's 40, well, how big is this guy? Well, that's going to be 40 cosine of 30 degrees. 40 cos 30, which is 34.6. So if this guy's 34.6, that means this is 34.6. Okay? All right. And what's our next one here? That was number 15. All right, 15, let's do 16. Big one, 6. All right, 16. Determine the other tension and the mass. Well, here we go. So you pull at 6 newtons at 40 degrees. There's a tension this way, and there's a weight force this way. So the question is, what's the other tension and what's the mass? Well, whenever I have a force at an angle, break it up into its two parts. So this side will be 6 sine of 40, and this side will be 6 cosine of 40. So 6 sine of 40 is 3.9, and 6 cosine of 40 is 4.6 newtons. Okay? So, that's going to the right. This guy's going up. And just like we did before, right? When you break something into components, okay, you literally taken this angled business and you've broken it up into those two parts. These two parts replace that. These two parts are that force. So now, if I got 4.6 going this way, that means I got 4.6 going to the left. If I got 3.9 going up, that means I got 3.9 newtons going down. Well, there's one last step you got to do on the downwards one. Weight is mass times gravity, so if you know the weight force is 3.9, you got to solve for the mass. So 0.39 kilos. There we go, there's 16. Big one, 6. Got two more. We got one more normal one. We got a 3-star. Here we go. Determine the other tensions. So we've got ourselves the mass, and you pull with 5 newtons. That's 70 degrees, so it's a very steep angle. And you have your weight force, and you have your other tension. So on this one, do the same thing. We're going to break it up into components. This would be 5 cos 70. This would be 5 sine of 70. 5 cos 70 is 1.7. And 5 sine of 70 is not. It's 4.7. So that's means I got 4.7 going up. I got 4.7 newtons going down. I got 1.7 going to the left. I got 1.7 going to the right. So the tension is 1.7 and the mass is 0.47 kilos. Make sure you divide by 10 to go from weight to mass, since weight equals m times g. All right. 18. 18 is a lovely problem. So I like 18. It's this is what dreams are made of right here. So you pull 200 newtons at 20 degrees, and this guy's going to be a little steeper at 50 degrees. So there's two ways you can answer this. One is conceptually. You could say, hey, that's 200. That means that's going to be bigger. So if it's a multiple choice question, I just pick the bigger one, right? That's one option, since the angle is bigger. The other is I could start to kind of plunk away at this thing, and let's just see what's going on. So I'm going to break this guy up into components. So this will be 200 cos 20, and this will be 200 sine of 20. So if I just do that, I get 188, and then my vertical 68.4. Now, let's go look at the other side. We're going to break his parts up too. Now, here's the key. On this one here, I broke into parts, and here I broke into parts. Well, I also have a weight force. Well, here's the key. If I look at these two horizontals here, right here and here, those guys cancel each other out. Well, if those guys cancel each other out, if that's 188, this has to be 188. They got to cancel each other out. Okay? Vertically, these are not the same, because this guy's holding more of the weight because he's steeper angle. But these two guys add up to the weight. So if I know how big this is, I know how big this is. So if that's 68.4, I don't know what that is, but if I know it, I can add these two together and get the weight. So over here, I need to somehow find that. If you do so, ka, to, this is the adjacent side. This is the opposite side, which is tangent. So it's a tangent of 50 degrees is opposite side over adjacent. And so I'd say the opposite side equals 188 tangent of 50. So 188 tan 50, get 224 newtons equals the opposite side. So this is 224. This is 68. Well, if I got 224 going up and 68 going up, what does that mean? That means I got to have 292 going down, because these two going up are supporting the weights. These two going up are holding it up in there. 18 again, there's a reason why I got 3 stars on it. Make sure that you got some SOHCAHTOA tackled to be able to tackle this first. You also could use the same method we did on a problem before. Is you could say, well, this is a tension, right? So I could say this horizontal piece, the horizontal piece equals tension times cosine of 50. And you could say, well, I know the horizontal piece is that. That's one way you could do it also to avoid having to do this tangent business. You could solve for tension, right? And then you could do a squared, b squared, c squared. A little bit more doable. So hopefully one of those methods work for you. Thanks for tubing in. Live the dream. Make good choices. Don't forget to wash your hands and be kind to each other. All right, guys, keep it real.